Good afternoon. I'd like to welcome you to the next in our series of Web Observatory briefings. My name's Ian Brown. I work directly for the Web Science Trust as a project manager. This webinar is a little unusual in that rather than being a specialist focus on a particular Web Observatory, it's a more generic introduction. At the start of the academic year, we like to introduce observatories to those who haven't heard of them before. This is a presentation that will be of interest to non-specialists from business, government, or new researchers who haven't run into the term before. Over the next 30-40 minutes, we'll be talking a little bit about the relevance of Web Observatory to web science. I'll introduce the Web Science Trust briefly. We'll talk about why the Web Observatory is a natural reaction to the way in which the internet and the web are developing. We'll talk about the types of data that Web Observatories look at. These are critical, of course, to building, designing your own observatory to understand what it is you're observing and think about whether or not Web Observatories therefore fit your own specific objective. So the Web Science Trust are a not-for-profit charitable organisation. We're based in the UK, although we are international in scope. We are focused on the definition of web science as a research discipline. We advise on the teaching curricula, the research frameworks, and various other policy issues around web science. We are kindly hosted by the University of Southampton, but we have members across Europe, North and South America, and Asia. The Web Science Trust contrasts with other related partner organisations in that we're interested in the application of web science, how the web affects society as society itself creates the web. That would be, I think, best seen in relationship to the Web Foundation, who are looking to establish the ethical and social elements of the web, internet and web access as a basic human right. The W3C are an organisation based out of MIT in the States, who are seeking to establish technical standards and ensure that the interoperation at a technical level between the elements of systems on the web are stable and defined. Lastly, the newest organisation, the Open Data Institute, based in London, is focused on the benefits around making data freely available. I'll talk a little later about the way in which the web has evolved from a web of pages into something more complex. The ODI is particularly focused on the impacts of access to data on the web, both in an economic and a social context. The single thread between those four organisations is a fairly familiar face, Tim Berners-Lee, who was originally on the board of the Web Science Trust. He's now our senior fellow, is the head of the Web Foundation and the W3C, and is also director of the Open Data Institute. Now, coming back to the way in which the internet has evolved, this is a fairly famous diagram now in internet folklore. This is, believe it or not, a diagram of the internet and all four nodes of it. In the 1970s, the purpose of the internet at that point was to understand more about moving messages around, resilience, and interoperation between networks. When the web was invented around the turn of the 21st century, it was focused exclusively on the transmission of academic material. So Tim Berners-Lee was attempting to ease the task of sharing papers written in different systems, on different networks, on different types of hardware. And what we can see over this period is the change in structure from the internet and the web back then to a view of the internet today. This is a visualization of traffic volumes, routers, and it's intended to give an overall impression of the complexity of the web. It's no surprise that this seems to resemble a human brain. This is many people have drawn the analogy of the internet and the web as being like a nervous system. But key to understanding the growth of the system is to understand how the complexity of the processes and the complexity of the material has changed. What was originally only academic material now comprises business transactions, interestingly both policing and crime across the same network, education, health, gaming, social networks, government, smart cities. Almost all social processes are now mediated by the web. And as those processes use the web, so the fact of their use can have an influence on the way these processes are done. I won't dwell on this slide except to say that this kind of slide is out of date almost as soon as it's published. But what it does tell you is not only the growth in complexity, but the growth of volume. There are literally millions of emails sent every minute, hundreds of videos uploaded, thousands of posts across the blogosphere. The size and the scale of interaction on the modern web certainly dwarfs anyone's expectations of its popularity and its scope. So to summarize that, what we're seeing is that the web is in some ways the largest piece of engineering ever attempted and ever achieved by humanity. It is an engineered object. It comprises cables, routers, switches, so it has a physical presence as well as a presence in what's come to be called cyberspace. The sheer scale in terms of its size and reach has an impact and must have an impact on modern life, given the way in which it changes how standard processes are performed. That makes it a highly relevant target to understand its impacts and to understand what it's doing to our social and economic evolution. The web needs to be proactively managed as a resource. Tim Berners-Lee predicted that beyond a web of pages, which we saw in the early days, moving on to a web of people in which almost anyone could create web pages and publish information, an age of data was foreseen. And not only would we have a web of data, says Tim Berners-Lee, but that data would be understandable by the web in such a way that the data would be actionable, and those would form hybrid so-called social machines in which humans and machines or intelligent agents would collaborate to execute certain processes and to solve certain problems. And in many ways we can argue that these social machines are all around us in social networks and in other processes and applications which exist on the web. Now, if we're going to live in this environment in which the nature of the system and the architecture can have an effect, then understanding what those impacts and what the structure means is quite important. And thus we are looking across all governments and educational systems to increase digital literacy. So first of all, at a simple level, that access to the web and access to the internet equals opportunity or potentially disadvantage for those groups that don't have access to it. but ultimately from digital literacy to a level of competency, to being able to leverage the benefits of those systems. Now, where our interactions with the systems generate large amounts of data, this data may best be made usable through the use of analytic tools and models at a technical level. Thus, the data simply in its raw form may not be usable or may not be suitably valuable. Thus, through a visualization, we might expect more benefit to come from access to this data. But similarly, in a world wrought with accusations of Big Brother and spying and traitorous acts by various people, the policy frameworks that underpin this data are critical, so that we can understand in what situations it is and is not acceptable to gather data, and in what situations it is and isn't acceptable to personally identify the people who are reflected in that data. So what we're looking then to do is to understand what data is required, what data can safely and ethically be gathered, how it can be analysed and visualised in a way that adds value to society, both in terms of social capital as well as intellectual capital and financial capital. It should allow us to understand ways in which the resources which are available to us can be shared and maintained and curated. There is no doubt that the abrupt halting of access to the web would be devastating to many aspects of business and government around the world, and so we should not underestimate the value that the web represents. Now, starting from a completely open model developed by Tim Berners-Lee, the current threat to the web as it was originally envisaged is the creation of so-called silos, in which some of the most successful companies have created walled gardens in which the data, which clearly has value to them as businesses, is corralled and kept locked up. To some extent, one can access elements of this data through Twitter feeds or through scraping of data on web pages. But ultimately, this infrastructure is about hiding data, and it's not about sharing it openly. This is in stark contrast to Tim Berners-Lee's original vision, and he famously appeared at TED, I think on 2 occasions, to ask for raw data, to ask for data to be shared by default. Open data as a default is an approach which has more recently been adopted by a number of governments in Europe and the States. So that's the background to the tremendous growth of the internet, the introduction of the web, and the move from a web of static pages through to a web of data, where that open data may be usable and beneficial if we can access it. So this brings me to an introduction to the Web Observatory. So an observatory in the classical sense is a building or a system used for observing events. So the Web Science Trust, and specifically Dame Wendy Hall, suggested this idea of an observatory based on earlier projects which have been undertaken by the astronomy community. So the observatory doesn't have to be a physical item or physical system. It can be a virtual idea. Now, physical observatories have been around for many thousands of years, and simply what's happened over that time is the technology that we've used to do that observation has changed. Now, what's different about observing the web in comparison to observing the physical world is that we need to understand the difference between directly surveilling individuals and observing the impacts of what they have done. So web observation is about understanding how specific data sets that are available on the web, these may be live feeds, these may be data contributed by the crowd in real time, or there could be archives gathered over time, how those data sets are stored, what they describe, and how they can be accessed. And to build on top of those a set of analytics and visualizations. These data sets can be thought of, I've heard them described as footprints in the sand. Thus, we're not looking at the individuals themselves who walk along the beach, but we are looking at the footprints they leave. And by looking at sufficient numbers of tracks, we can understand more about the directions and paths that people generally take over time, whether those things change, whether there are other factors which affect those paths. Once we have those data sets identified, there is of course a need to harmonize the standards underlying the infrastructure and the storage of the data. We are trying to move away from a walled garden approach, the siloed model I showed you earlier on. And we're looking for a way in which anyone who gathers or publishes data on the web can share that with other users in a network of observatories. Those observatories might not only offer data sets, but might also offer the benefits of their specific analytics, their visualizations. Some organizations will be particularly skilled at analyzing the data rather than gathering it, or visualizing the data rather than analyzing it. And that would allow us to build virtual communities on specific subjects between researchers who wish to analyze the data, practitioners who gather the data, and maybe governance groups that are looking to understand the impact of data. Now, in order to do that, we have to stress the importance of digital literacy, leading to an effective and meaningful approach to gathering, curating, and publishing data. And that may allow us to understand the way in which this data sharing and interaction on the web creates social machines and how those social machines impact the way we live. Similarly, with the ability to analyze behavior within these social machines, governance becomes easier, and instrumentation of the machines in terms of creating alarms or alerts can give us an early warning around the idea of failing social machines, attacks on the web, or other attempts to influence this open and shared system. So specifically, the Web Observatory is going to analyze elements of the web. That may be data on the web, which we can think of as content or data which is explicitly put up on the web, and indeed data about the web, or more correctly known as metadata, which is data about the data. The Web Observatory can be used by academics in order to support their research and to provide real data behind the research papers which go out in a way that makes research extensible and reproducible. However, we anticipate that government will also have an interest in Web Observatory in order to look at policy, to look at the impact of systems on social behaviour, and of course business will want to leverage the Web Observatory to understand how markets work and develop their understanding of their own customer base. Now, when building an observatory, generally we would start with an understanding of what is to be observed. The data to be observed really runs across two axes. The data may be completely open. We've talked a little about the Open Data Institute, meaning that there may be no licenses associated with the data, or there may specifically be licenses which allow reuse under certain terms. The opposite of open data is private data. We certainly don't assume within the Web Observatory community that all data will be made public to all people. That's clearly a fairly naive position, and we'll talk a little bit about that in a second. So data will move on a freedom access from completely open to completely private. But a second access is probably also worth talking about. Big data is a fairly common concept these days. Big data generally is associated with enormous volume and velocity. Also variety and a number of other V's depending on which authors you subscribe to. But the fundamental issue with big data is one of size and velocity, the ability of systems to keep up with the processing rates required. Now, at the other side of this diagram, I've cited a concept suggested by my colleague Professor Jim Hendler at RPI. Rather than big data, he talks about broad data. And broad data is really sources of information from multiple systems in multiple formats, multiple areas. And this is in many ways more akin to the web science approach. It can be very interesting to triangulate an answer from numerous sources rather than simply analyze a large data set for correlations. So the second axis that one should consider here is whether your data is big, i.e. there is a lot of it from one source, or whether your data is broad and that you are analyzing from multiple sources. Thus, when we decide which data sets we are going to use and access, the key thing is to understand which of these data sets will be completely open, which of them can be shared under specific circumstances or specific licenses, and largely which ones are private or internal data sets. And it's likely that a set of data may comprise one or more of those types of sharing. So in order for us to build observatories, we need to encourage new users to develop their own observatories, to extend existing systems to act as observatories, or to download an open source tool which offers an observatory functionality, and to create an ecosystem, and more importantly, a community focused on sharing knowledge and applying it. Now, that is going to allow thought leadership in a number of areas, government, business, and academia, and will place the focus squarely on evidence-based decision making. This is rigorous research based on data, where the analysis can be rerun, where the analysis and the underlying data can be shared. We're looking to go beyond simple correlation, which is typical of brute force big data analysis, and to understand causation. So we are trying to get behind cause and effect relationships. That can comprise analysis of historical data, looking at trends over time in a kind of hindcasting fashion, as well as simulations and modeling in order to attempt forecasting and modeling into the future. Now, how is this done? Data sets are more usable if they are linked. Going back to Tim Berners-Lee's TED Talks, on the one side we can share data in its raw format, be that simple comma separated variable data sets, or more structured formats such as XML or JSON. Ultimately, what we are looking for is to leverage the power of the web, in which the links on the web can link not only to websites, but can link to physical objects and data sets. Here you'll see a map of the most recent set of global linked data sets, starting in the middle with the linked data version of Wikipedia, which is known as DBpedia. And I leave you to study this diagram. Suffice it to say, the number of linked data sets has grown substantially over the years. If you can produce your data and maintain your data as linked data, it is more useful to other parties. Why would you do this? Here's an example again from Jim Hendler about pulling broad data out of a number of systems. Here he's showing the example of the number of forest fires, or the acres burned during forest fires, versus the Department of Agriculture budget on preventing forest fires. And we can see a close correlation here between spend on prevention and actual savings in terms of damage. Other applications of this sort of technology are in event detection and prediction. This is an example where real-world events, such as those that can be gathered from sensors and transducers, weather, temperature, traffic sensors, can be linked to models predicting behavior. So the ability to model actual behavior from historical data has been shown to be quite powerful. This is an example of the famous Google Webflow research. I should say there has been some debate as to the robustness of this model after 2009, but Google analysed the number of cases of flu from CDC data and correlated it with a very, very large number of fairly random Google search terms in order to select those Google search terms which most closely approximated the incidence of flu. And by providing this analysis, we're able to predict the outbreak of flu between 10 and 14 days sooner than the CDC themselves, whose access to data was much slower than Google's real-time access to search terms. Within the Web Science Trust Network, we have active examples of modeling data. This is an example of a system called Event Shop, which looks at flood data. It keeps a model of where flooding can occur. It uses satellite imagery and databases of suitable shelter during flood conditions, and allows individuals to register for the service, who are then notified of where to go given their current location, the current level of flooding, and the availability of shelter. This is an example of broad data where multiple data streams are brought together to solve a specific problem. So this is a diagram from my colleague Thanasis Tirapanis, talking about the ways in which we need to collaborate in the creation and sharing of web observatories. Starting on the left-hand side, we understand first our data sources. That can be internal organizational data. It could be open linked data in the cloud that we looked at earlier, and it could be real-time data from social media or crowdsourcing. Once that data is harvested, we can offer analytics and visualization through a harmonization process so that different data sets can be analyzed within the same model. Visualizations and visualization tools provide a non-technical interface for users to access this data, I think we have to be increasingly aware that not all researchers are either willing or able to write complicated code and models to analyze this data. Once specific models are built, such as the event shot model I showed you, these will iterate through a process of review and improvement, and will be released as social applications. The effect of those social applications can themselves be fed into research, and that closes the circle in which revised sets of data or different approaches are used to refine and improve the application. What does this look like physically? Here's an example of an overview of the Southampton Web Observatory. I won't dwell on this, but suffice it to say, this reflects the three-point nature of the observatory. We have multiple data sets which will need to be converted, enriched, having been harvested from multiple sources, the blogosphere, social networks, and those create a set of data catalogues. Those catalogues are advertised out to the community so that other organisations are aware that those data sets exist. There is then a method for sharing that data set provided. If the third party doesn't want to access the data directly, they may choose to access the analytic tools. They may look at visualizations or analysis of the data, or similarly, they may use their own analytic tools to work on the data that's been shared from another observatory. Similarly, access to this will be via a variety of portals, and those portals will allow secure access to permitted parties, making the distinction between open data, shareable data, and closed data. There will be a process of citation, publication, and visualization. We would expect the variety of front ends to be quite large. So what are we trying to do in summary? We are trying to understand what's happening on the web. Professor Les Carr at Southampton talked about taking the pulse of the web, mapping this space that we move in order to understand how we affect this space and how this space affects us. Our view here is to provide a layer of infrastructure and standards to access this data. Particularly, we are keen to give access to non-technical researchers who bring extremely valuable insights from their own disciplines, but may be prevented currently from using the data on the web through lack of technical expertise. So shared infrastructure and technical expertise will help to provide access to the data. And once we give access to the data, interdisciplinary expertise will give us a much deeper and richer understanding of interaction on the web. This is to be seen across a backdrop of digital literacy, not only for researchers and users, but also businesses and government. So ultimately, we're looking at the Web Observatory as a shared platform. Individuals may operate their own observatories on specific topics, but once we link many of those observatories together, we achieve a global web observatory or a worldwide web observatory, which can be seen as a highly accessible and safe harbour to work with data, to understand as close to real time as we can get it what is happening on the net, and to do that through a process of largely anonymous and aggregated analysis rather than individual surveillance. The Web Science Trust is looking to promote this approach. It's attempting to be a disinterested, trusted partner. The Web Science Trust is a not-for-profit organisation. We're looking to foster research between our many academic lab members, but also we are increasingly inviting commercial labs, and we're starting to talk about public sector labs to bring together highly valuable data sets in a way that will inform policy, inform social challenges and economic frameworks. So in conclusion, I would like you to consider the Web Observatory as a way to better understand the web, as a way to document the impact of the web on various social processes across a whole range of topics, and to link that analysis back to the research so that any conclusions and any analysis which derives from the observatory can be shared and can be improved upon and reproduced. As we see the growth of the Internet of Things, we will see ever more data available telling us who has done what and where. We need to avoid the temptation to surveil individuals, and we need to focus on aggregated group level analyses which are safe and ethically sound. Access to this data needs to be kept open source with a Creative Commons licenses, and like all networks, the more nodes we can add, the more partners we can add, the more valuable the services will become, and the wider the scope of the benefit. For your own post-talk homework, I would ask you to consider how might the Web Observatory be usable within your own context. Would you be prepared to build an observatory? Would you be prepared to extend an existing system to become an observatory? Are you able to share key data sets? If any of those areas are of interest to you, I would encourage you to contact the Web Science Trust, and we may be able to help you install a web observatory, share a data set, or otherwise play in this space. So I'd like to thank a number of my colleagues who provided input for this talk, provided slides and graphics, and I hope this has been useful for you. I'm more than happy to answer any questions. You will find a link to post questions on the Web Science Trust website. So I hope it's been useful for you, and next month we'll get back to looking at a specific example of web observatories or specific technology. So enjoy the rest of your day. Thank you.